Alright, let's start. I'm gonna be doing less of these live streams at this time because I'm uploading. I made a new channel to upload the videos, and I'm gonna upload. There's a bunch of them that I have to upload. So, and when I live stream and I upload them at the same time, the live stream gets delayed, and the quality is not very good. So. Until I upload all of them, I'm gonna be doing less hours and less of the videos. Let's start right away. Actually, let me train a little bit of this typing thing. Oh no! It's super low. I'm training a different way of typing that uses more fingers because I'm used to only using a couple of fingers to type, and it's very slow. So this way is slower now, but I will get faster in the future. A lot more faster than I was. Oh. For example, if I type like this, it's a lot faster, but there's a cap, a limit to how fast I can go. See? Okay. Let's start this. Find the missing letter in the past letter range and return it. If all letters are present in the range, return it. Fine. Find the missing letter. So it goes from A to Z. -1. -1 shouldn't be the case. I want the last number. Last number of an array. And this is a problem because I'm going to create a variable that is equal to the alphabet, and I'm going to compare this variable to a string. Is that how you talk length? Don't remember. GTH. Oh, there's a problem here. This mouse is double clicking out of nowhere. It's really annoying. This should be here. Index of oh, it's actually -1. Last index. So I don't need the index of here. Just like this. In here. Now how can I say this is gonna give me should be string here instead of alphabet. Alphabet I+1. I'm not sure if I can do this, but inside of here. So when it reaches the last value of the string, it's gonna add 1 to that index and return the alphabet value of that. And if the string is equal to the alphabet, returns undefined. I think you can delete this return string here. Okay, so this one is right, the other ones are wrong. So probably this way of saying this is wrong. Let me put this on Python tutorial, see what's happening. String I is not being equal to -1. Oh, I know. How can I say this? No. A string of -1. If let's see how this runs. Why isn't making it equal? Well, I think it's because the string -1 is not a value. Maybe if I do this, so I need to put a space here. Now it should work, I think. Maybe if I split the alphabet too. Now I have all letters on an array. I have a feeling it's not gonna work, but so this should loop through the array, entire array. No, but then the undefined is not gonna work. Now let's see. Maybe it needs to be a nested loop, nested for loop. So maybe I'm gonna do a nested for loop here. I'm not sure if it's string.length or alphabet.length. I think I'll comment this out first and see if it works, and if it doesn't, then because I'm not sure if the string is gonna have it should have an index from what I know, but might not be the case. No, it's this. Let me see what's happening here. So it is finding but returning the wrong value. Returning B because I is 0 when it finds. So I need to find a way to specify which letter it is. I know what to do. No, that doesn't make sense. This is the one. This is the one. Let's see what happens now. And this undefined is working. I'm still returning B. Maybe if I put this inside of here. Oh, I can also use regex to do this. I forgot about that. Now it's too late. Maybe I just take this for loop out. And see what happens. I'm gonna do this, see what it returns. It's returning A, so I plus 1 is not gonna work. And it's returning A because it encounters in the first loop. Index of is not fine. String index of. Turning A still. Oh, because it's stopping at A. That's not what I want. No, it's not gonna give me equal. So what if I split here? Why doesn't give me that is equal to it? Undefined. And this is gonna teach me a for loop. Oh, that's a much better idea. You can just pop. Then I loop through the thing until it finds. So the issue here is not making it equal. Well, it did return F. Here, what's wrong? Oh, it's not necessarily the last one. I don't understand what does it mean by that. Find the missing letter in the past range. The first one, the last one. What does it mean by missing letter? I think I need a nested for loop. I should loop through string first. this pattern here and compare it to the entire alphabet. Yeah, maybe that's the thing we should do. Why is the same and it's different? want each value of the array of the string to loop through the alphabet, searching for the pattern. We can use math as well. Function because it's not a string. Oh no, at least two of them are. Returning D. should be returning D, which is right. So let's see what's happening on this one. Turns A because it's the first letter. That's a problem. It has to start. The loop has to start in the beginning of the string. So why is not starting in the beginning of the string? Oh, it is starting, but it's alphabet I. And I is going to be equal to 0, so it's going to start at the beginning of the alphabet. So it can't be alphabet there. How can I make it so the alphabet string starts at the same level as the string starts? Maybe another for loop. Maybe if I loop to the alphabet instead. Let's see. So this check here should only start That's what I want to do. And then it's gonna string up map. Let me see something. So charts only works if it is a string, so I can't use map really. For each maybe. Internet's not working. That. I'll wait a little bit. can I say this? I want it to start when the string starts. I'm looping through the alphabet. So alphabet I is gonna be and if I change from string, it's not gonna matter either. So first it needs to match. First you need to match the first letter with the alphabet. For when string 0 is equal to alphabet I. And how can I say this? Maybe for each is gonna work. But it doesn't work on my string, apparently. Maybe this one. No. Maybe another for loop here. That is not gonna work. I know what I'm gonna do. Maybe this works. Because when it meets the condition, it's gonna loop through the alphabet. And then it's gonna but then I is gonna be equal 0. I don't think this is gonna work. I need something that loops through the string starting from. It loops through the alphabet starting from this string. Yeah, I'm back. What if first I loop through the alphabet to find the first match? So I want to find the first match. me see what this code does. No. What's wrong with this? Oh, I think that's what's wrong, I think. Yeah. Okay, so this returns 1. Which is the first value. So I think I need to put this inside of the thing. I need to put this inside here. And this is gonna give me this is gonna make the I first thing. No, I put this inside of that. Let's see if this works. No. Infinite loop. I know. Maybe it's the other way around. I want this loop to start at this position. So this is gonna give me the index that I want to start the ladder loop from. See if this passes. Because I'm returning J. So I'm gonna store this number in a variable. Oops. Maybe I just need to put this inside the thing. Instead of having return J here. Maybe this works. Let's see how this works. I don't understand why this is not working. You see that the alphabet I is different than the string, but it should be the same because they're both B. Maybe it's alphabet J. Here. Let's do return B. Try J maybe. It's the same thing actually, because I made I equal to J. So it doesn't matter. Why are these ones working? That's the weird thing. It's because they started the BC. That's why they were. And this doesn't work because it starts later. So they have a different count. What's the issue here? It's taking a different character. So J is 1, I is 0. I'm just looping one more time, I think. Oh, it's because the J is not changing. That's why. So it's always testing for the same letter. That's the problem. J equals 1, I equals 1. Alphabet 1 is supposed to be B. And the char at 1 is C. So -1. Let's see what this does. So what's wrong? It's giving me the correct answer here. And for some reason it's not working. I have a feeling this is gonna forget about this. Let's test a different one. Let's see what happens there. That's weird. Now is it turning 8? Oh, because it starts the same. Better. That's the problem here. There's so many curly braces. Let me see. This. It shouldn't matter. The order. This is confusing as fuck. I'm not sure if I need this here. Because when they are equal, then this if statement is going to be irrelevant. Let's see on the footer. And this is the one that's wrong. There's obviously a better way to do this, but so returns the first letter. And it's counting the J, not the I. Because I'm looking through this string, but since it's bigger, it doesn't. should work, I think. So string is maybe is a chart string instead of a -1. What's the value that has u? So when they're equal, it works because in chart I is going to be 0, which is equal to the alphabet notch, which is 18, should be S. Oh, the J is not changing, that's the problem. So the J stops changing. No, this is JavaScript. I'm using the tutor just to see. So what's wrong is that the J is not moving with the I. So I need to find a way to maybe if I add J inside, if I add +1 each time inside of this loop. I think now it's gonna work. Now returns T. So it should be at the end, not here. Use this bracket. Use this bracket. Let's see now what happens. I think now it works. Should be working now. Let's see. Yes, finally. Let's go. It's probably like there's probably much easier ways to do it. For sure, but I didn't want to erase all the progress I made. And your logo on Twitch says VMS code, and on YouTube it says VSM code. Oh really? I need to change them. On where, you say? Here? Oh, here, in this image. Oh. Yeah, I'll change that later. Thank you for telling me, man. I think I got the wrong image, but I'm gonna have to change on the canvas thing, this. It creates a variable with the index. If code of current character is not equal to first character plus no of duration hence character is being escaped. Yeah, I don't understand this one. Yeah, I think I spent a lot of time on this exercise. It's good though. I'm getting better at understanding the commands and stuff. String char code at 0. I don't know what this command is. 0 and this number at the given index. So it returns the index of the So why JS? Because I'm trying to learn. I don't know what I want to do in the future, but I'm just learning from the progression that I think is the best one. I started with HTML, then CSS, now I'm on JavaScript, then I think I'm gonna do all the free code camp stuff. And then I'm gonna see what I can do with that. Probably I'm gonna do the projects, the 30-day project thing on JavaScript, then learn Python, then C++. I think that's the best way. Because I've heard that C++ is the hardest one, then Python, and JavaScript, HTML, and CSS are the easiest ones. You're doing FCC, makes sense. What are you wanting to create with code? I'm thinking about maybe starting a company or looking for a job. Maybe as a freelancer or on a company somewhere. I have a bunch of ideas actually of apps and stuff, software. I thought about a bunch of them. But it's hard to do marketing, you know. So it might be better to find a job first and then go from there. Thanks for following, man. Peace Sudo? I don't know what to say there, this nickname. Compares the string here. It's similar to what I've done. I don't understand how you can do this without creating a variable for the alphabet. It takes two arguments, letter and index. Where is letter specified? Now letter is going to be each one of the variables. Each one of the letters of the string. Or maybe it's a special thing. As in left row or letters character codes. I'm not sure if I understand this. There are no missing characters returned undefined. Equals 1. Don't understand why it starts at 1 here. Also, if the difference in index is bigger than 1, from charcoal, string charcoal, character code. I guess this, I need to read about this character codes and watch videos about it so I understand better how they work. Check if the difference in character codes between adjacent characters in the string is more than 1. Return the missing character, +1 from the gap was detected. So I understand that it looks for where there's a gap, and then it returns the character that the gap is, but I don't understand how does it know that there is a gap if only has the string as argument here. That's what I'm confused about. So I assume there is a way for JavaScript to loop through all the characters on the alphabet, and this is the commands that do it. Variable, just normal for loop. So it's gonna loop until they're different. New string all chars is created. Creates a regular expression of chars which selects everything except string. The for loop is used to add all of the letters in the range to all chars. Match is used to strip off the string letters from the newly created string, and it is returned. There are no missing characters returned undefined. I kind of get it, but not really. Okay,
hello friends, welcome back.
This video, then I'm gonna watch some videos about this char code at and char code from, and then after that I'm gonna be done for today. But first I'm gonna grab some water. Right back.
Today we're going to find missing letters. We want to find the missing letter in the past letter range and return it. If all letters are present in the range, return undefined. Okay, so A, B, C, E should return D. A, B, C, D, E, F, G, H, J, K, L, M, N, O should return I. Got it. Okay, so this should return undefined. So let's say alphabet. We're going to say let alphabet equal here, and then the string. Well, first off, the thing about this is that we have to think about starting from S, right? That's the tricky part. I'm going to let the result equal here no, and then we're going to console.log the result. Right now we're just returning the string, and so what we want to do is say, well, we could console.log, that's, okay, string at position 0, right? What does that give us? That gives us an S, right? And then in the alphabet, alphabet.index of string. This gives us the index of the letter S. 0, let's start with B. That should be 1, right? A is 0, B is 1. Okay, so this is S. What we want to do is start at position 18. So, yeah, this string, the alphabet at position 18 is equal to S. So, yeah, we could just, initially, I'd say what we should do is set the, this guy 18 to just be, let's call this the starting position. Starting position equal this guy. And now if we were to say console.log the alphabet at starting position.
So he also
Okay, cool.
created
So,
a variable called
I mean, one thing that we
outline.
could do is just iterate up to the ending position, right? Because we'll be able to say DEF, CDEF. I mean, it's theoretical. No. I'm thinking about this like if it were just B, C, D, F. Oh, it needs to return the next string. So, yeah, we actually don't need an ending position because if it's B, C, D, E, F. Oh, I wonder what it should be if it were B, C, D, E. Anyways, because that's not part of our test cases here. We're not going to worry about that right now. We're just going to iterate up from the starting position. So what we could say is we're going to say we're going to let this let I equal the starting position. I is less than the string dot length, and then we're going to increment up with I. So yeah, now if we were to console.log I think that starting position less than string dot length. Console.log I. It should be counting out the STVWX. We're starting. I plus 1. Console.log I. Console.log alphabet. At position I. Doesn't make a difference. It's console.log starting position. The starting position is 18, so let I equal starting position. I is less than the string dot length. Oh, okay. String dot length is 4, so it needs to be I is less than string dot length plus the starting position.
So instead of doing the loop, it used index off and put string 0. I tried this actually, but I was probably doing something wrong. I wasn't creating a variable and making it equal to index off. And that's how we got the initial position.
Yeah, starting position plus string dot length. Starting position plus string dot length. Okay, so yeah, it needs to be 18 plus the length of the string.
Position.
If we initially I had it set to the string dot length, which is the length of the string is 1, 2, 3, 4, 5, and so we're starting I at I starting at 18, and we're saying well I is less than 5, I being 18. That made it so that this didn't run, and so I'm just going to expand this just to show what's going on here. So I hope that makes sense. We need to have the starting position plus string dot length, and now we're iterating through STUVW, right? STUVW, and well, what we could do now is say is alphabet at position I, is that equal to our string at position I minus string minus the starting position. True, false. And so, yeah, right. So what's going on here? S, T, and then at U, it becomes false. And so, yeah, I mean, here we can say not equal to here, and then we're false, false, true. So what we can do now is just create a conditional statement, right? Like if the alphabet at starting position is not equal to the string at starting position, then we return the alphabet at position I, and that'll give us U, S, T, U, V, and that is what we're looking for. Right here, we're producing that. This is it's kind of a weird way of going about it. Run the test. I think they pass. Okay, cool. This is a way to solve this problem. Yeah, I mean, this works. Is there a cleaner way to do this, one that makes more sense? I'm not sure. Okay, yeah, I found a better way to do this.
So if alphabet I different than string, I minus starting position. Yeah, which is the same thing that I did. But I used character at instead of this notation. And then I didn't need to use the for loop because of this is a simple, easier way to do.
So all this indexing stuff and the starting position stuff is annoying, and it makes for the code to be very illegible in my opinion. So what I want to do is I'm going to create a variable called the focused alphabet. Okay, and we set that equal to the alphabet dot slice the starting position, right? And let's console log the focused alphabet so you see it. It's not splice, it's slice. There we go. And now you see we get STUVWXYZ. So we've simplified the alphabet so that we can actually iterate from the beginning, and then we can just compare that with the actual alphabet. So instead of saying I is equal to the starting position, we can just say 0, and then the I is less than the string dot length, right? And so now if we were to console.log the string at position I, and then the focused alphabet at position I, we get well, let's get rid of this if statement for now. S, T, U, V, and W. And so now we're comparing them in a much more simplified way. Now that we have this focused alphabet, we know that, or we're just working on these elements. And so what we can do is just iterate through, and we say if the alphabet or if string at position I is not equal to the focused alphabet at position I, we get rid of the starting point mumbo jumbo. Then is this equal to this? Yes. And then we skip the if statement. TT, is that equal to that? Yes. So we skip this if statement. VU, is that equal? No, it's not. And so what we do is we return the alphabetical number, which is STU, the one that we're pulling from the alphabet. And then we never even have to go to the next point. Nice. I wonder why it says C down here. C, huh. If you're an STUV, why is it passing back C? This is not passing the test. Oh, because what we're doing is we're passing in from the alphabet. So in this situation, our index is 0, 1, 2. And so at index 2, we're saying at index 2, we're checking the alphabet, which is 0, 1, 2. So we're passing C. So what we need to do is say focused alphabet. Now we're getting that one. We can get rid of this console log, and that will just give us the U, which is the result that we want, and that makes the test pass. Now this, I think, is way clearer to understand, right? We first set the alphabet. The next thing we get the starting point from our string, and then we throw in our focused alphabet, which means we just get the data that we need to solve the problem, and then we just iterate through.
I'm not sure if this goes. site. Canva, yeah, that's the name of the thing. So I'm gonna watch these 2 videos here, and then I'm done for today.
Write your truth and believe in it. And if your mother doesn't like it,
How's it going, guys? My name is Dom, and today I want to talk about the string.from_car code, or the string.from_character code method in JavaScript. So essentially, this method allows you to convert a character code, so a number, from the character code into the character representation in Unicode. So let's just see with an example. Let's just create a new variable here, and we'll call this one something like char, so character, equal to the return value of the from_car code method. Let's just say string.from_car code. Inside here, let's just pass in a character code. So we know that Unicode supports all of ASCII. So if I also bring up the ASCII dictionary here, that we have obviously the decimal number on the side. Let's just print out a capital D. That'll be decimal 68. Okay. If I was to pass in 68 into this function here, car should now have the value of a capital D. Okay. Let's just console.log car. Okay. If I was to save this one and refresh the browser, we get a capital D right there. Perfect. Okay. So this method takes in a whole number, but it also supports things like hexadecimal. So back to this ASCII chart down here. Let's just pass in the hex 44 instead of the actual decimal number. Let's just go here and just say 0x and then 44. Okay. You now save this and refresh the browser one more time. All right. And we still get a capital D right there. So you can see how it supports those 2 bases of numbers. Okay. So this also can take in multiple parameters, and basically it's just gonna append to that return string for each parameter that you actually pass in. So if I was to actually make this car have the value of something like a D code, like that, we can achieve this using this method. So let's just pass in 5 arguments here, 1 for each letter of D code. So back inside this ASCII chart, passing in a lowercase d, so 100, then a 99, and an O will be in 111. So we'll pass in 100, 99, 111, and 2 more. So D code and E again. So D, we have 100 again, also 101. So let's just say that, and 100 and 101. So now this car should now equal D code. Let's just save this and refresh the browser. See how we go. Make it D code right there. You can see how it supports multiple arguments, just like that. All right. That's how you can use the string.from_car code method in JavaScript. Thank you for watching, and I'll see you later.
Maybe I need to understand what the decode is. This representing the UTF-16 code unit. Explanation. No, 1 hour. I watch this show.
Hello YouTube, this is Mary from Happy Coder. The mission of my channel is to share with you my experience of learning programming languages and my understanding of some difficult points in hope to assist your learning. In this video, I will show you 2 JavaScript methods. Before getting to how these methods work, we have to know what Unicode is. Unicode is a computing industry standard for the consistent encoding, representation, and handling of text expressed in most of the world's writing system. Basically, it tells us that each letter, number, and symbol, such as @ space, etc., has a Unicode, which is a unique number representing it. In today's video, I'm using ASCII code as examples. The value 0 to 127 of the Unicode is called the ASCII code, the American Standard Code for Information Interchange. It was designed to represent characters in the English alphabet. You can see the ASCII code in the table on the screen, with letters and number highlighted.
It's kind of like
now we know the Unicode. Let's see how it's relevant to the methods I'm teaching you today. For illustration purpose, I'm using an application called Brackets to show you my entry on the left side of the screen, and simultaneously you can see the results on the right side of the screen. First, I want to show you the method string.carCodeAdd. This method returns the Unicode value of the string index. In brackets, you put a number greater than or equal to 0 and less than the length of the string. If it is not a number, it defaults to 0. Remember, the index of the string starts at 0. You can type in a string directly in the string place, or you can use it as a variable and assign a value to it in your script. Let's change string to capital letter A with quotation marks. Ctrl S to save the change we made to the code, and you can see it returns 65 in the browser. Change the letter to B, it returns 66. Change it to C, it returns 67, so on. And now let's type in string capital letters A, B, C. If you don't put anything in the brackets, it returns 65, which is the Unicode value for capital letter A, as this method defaults the index to 0. If you put 2 in the brackets, it returns 67, which is Unicode value for capital letter C. Next, let's look at the second method, string.fromCarCode. This method returns a string using Unicode value, which are typed in the brackets. The first letter of string is in uppercase, as it always returns a string, not just a string object. In brackets, you put in a number or a sequence of numbers. Let's try typing 65 in the brackets, and you can see the capital letter A in the browser. Typing 66 returns capital letter B.
So Unicode
Typing
is the
67
way
returns
that
capital letter
the
C.
computer reads
And
the
now let's type in all
alphabet.
these three numbers with commas in between.
From what I
String dot from
understand.
hardcode 65, 66, 67. It returns a string, capital letters A, B, C. This wraps up today's video. Hope you've learned something. In my next video, I'm going to show you how to use these two methods to solve a problem called Caesar cipher.
Let's close
Please subscribe.
this. There's this first.
I always talk about the ASCII table when dealing with characters. But in JavaScript, that doesn't really happen. That's because it's a bit more hidden behind the scenes, the ASCII table, the actual UTF-16 table. In this video, we're going to talk about how you can convert a UTF-16 value or ASCII value into a character and back. So let's start simple. We have here a string, just a simple string, ABCD, and I want the ASCII code or the UTF-16 code, but for the same for these types of characters, I want the ASCII code of the first character in this string. So how do we do this? Well, first things first, we can get the character, right? We can say str.char@, right? And we can say here 0. Simple enough. And if I try to console log this, we should actually get A. So it makes sense, cool. Now, using a similar method, what you can do is get this, the code of that character, the Unicode value of this character, instead of just the character itself. We can say here char code at, so char at, index 0. And that's going to return not just the character A, but the ASCII or the Unicode value of that. Right? If I try to run this now, you notice I get 65. That's the correct answer for it. Now, how do you go from this to this, from this 65, how do you go backwards? Well, let's start with just a simple number. Let's say here, let num equals this 65. What you can do is call a function from the string class called string.from charcode. And this guy is going to convert back whatever you pass in as the ASCII or the Unicode value in here. So if I have here 65, which is our number, and let's also console log this, you'll notice that I'm going to get back A. So as you notice, this way really works nicely because all it takes in is just a number or any number of numbers. I can have here also 66, for example. It's going to pass it in as well onto the same string. That's going to work. The idea is we just have to pass in the one number. But in the previous example, we had a whole string and we had to call a function on the string. As it turns out, that's the only way to do it. So if you want to, for example, get the ASCII value of the character A, what you have to do is say, here, let's call this str, and you're going to have to do str dot, again, charcode at 0, right? And what you can do is, instead of having this a variable, just remove this whole thing and just say the character A itself. And that's going to work. It's very simple, and you can sort of understand what it does. It's decently readable, right? So now, if I try to console log this little guy, you'll notice I get 65. So that's the correct answer. So this is how you should turn numbers that represent the ASCII values of certain characters into characters and backwards. I hope you got something out of this video. Thank you guys so much for watching, and see you next time. Take care.
I think I kind of understand what's going on now.
In the last part of this series, we saw how character encoding went for a toss when people from different regions speaking different languages, started encoding characters to suit their language. And the whole process of communication using computers sort of broke down, with file transfers and emails, etc., across different regions and different languages. So the Unicode consortium came into picture, which was a group from different countries and companies whose job was to encode all the characters that exist in the world in a way that there are no clashes. Now, in the beginning, Unicode started with a fixed width 2-byte character set, but it soon fell apart and is not in use anymore, okay? But that has led to a myth that Unicode characters are all 2-byte characters, okay? But that is not true, as you will see in this tutorial. Now, during the ASCII days, characters were mapped to integers. And because we were using a single byte to represent characters, there was hardly a difference between the integer that the character was mapped to and its representation in memory. At least that was not discriminated consciously. For example, the character A was mapped to the integer 65, which in binary was represented as this in a byte. So saying that A is mapped to the integer 65 or saying that it is mapped to this binary sequence was kind of one and the same thing. But Unicode approached this problem differently. They said, let's first map all the characters to integers, okay, which are just numbers, and that is step 1. But how we represent these integers in memory or how many bytes to use to represent this integer is altogether a different thing. For example, A could be mapped to the integer 65, which is called its code point. So 65 is the decimal code point, while 10000001 is the binary code point for the character A, and we have not represented it in memory yet, okay? But when we define how to represent it in memory, that leads to different encodings, which are all Unicode encodings. And this is a very crucial idea because now, if an encoding has some problems, it can be phased out or discarded in favor of a better one. And that's how we see that there are tens and hundreds of Unicode encodings, some of them being minor variations of each other. But UTF-32, UTF-16, and UTF-8 schemes have become the more popular ones. And out of these three, UTF-8 has almost become the de facto encoding scheme for web applications, and for good reasons. Okay. In this tutorial, we'll touch upon these three encoding schemes, and it's not going to make you an expert, but you will understand enough what's really going on behind the scenes, especially if you work with databases or are a software or web developer. In this part, we'll talk about UTF-32 and UTF-16. So let's get started with UTF-32. Now, UTF-32 scheme said, let's store the integer in 4 bytes or 32 bits. So it is a fixed width encoding scheme because the number of bytes to store the integer is fixed. Now, this code point represents the character A. So how do we store it in 32 bits? Well, it's very easy and straightforward. We store it like this. And this is the memory representation of the code point for A in 32 bits or the UTF-32 encoding scheme. Here we fill all the bits of the code point from the right side and fill all the remaining bits with zeros. This is very simple, straightforward, one-to-one mapping and should have been widely used but for one big problem. And the problem was that the English-speaking world didn't adopt it widely because for them, each of the characters needed to be converted to 4 bytes from one single byte. And that would mean that if there was a file of size 1 KB, containing only ASCII characters, it would become 4 KB in UTF-32 without adding any more information. Not only will it affect the data transfer times, it's actually a huge wastage of memory, okay? Moreover, porting all the existing data to the new style of encoding itself was a huge deal. So UTF-32 sort of took the backbench. Now, this is a pure engineering problem, okay, to be able to have something which works for all the existing stuff as well as the new characters that are known or will be known later, which are yet to be encoded. So another solution in the form of UTF-16 came up. Many people think that as UTF-32 is a 32-bit character set, UTF-16 is a 16-bit character set, and UTF-8 is a 8-bit character set. But that is not true at all. In UTF-16, the code point may be represented either in 16 bits or, if required, in 32 bits. That is, either one chunk of 16 bits or two chunks of 16 bits. So this kind of character set is a variable length character set because the width of bits in memory is not fixed. Now, what is the advantage over the fixed 32-bit representation? Well, at least for ASCII, the size of files will not be 4 times, although they will still be twice the original, and it is still not backward compatible with ASCII. That is, a file containing ASCII characters in the old ASCII format will still need to be converted to UTF-16 encoding if some software wants to read it as UTF-16. This point will be more clear to you when we talk about UTF-8 in the next part. By the way, let me point out that the Unicode code points have been mapped in such a way that the first 127 integers are mapped to the same characters as in ASCII. So how do we represent this code point for A in memory using UTF-16 encoding? Well, this binary representation can fit in 16 bits. That is, we will not need 32 bits in this case. So we can fill the first byte with all zeros and the second byte with the required bit sequence. Now here I have used hexadecimal numbers to avoid using up a lot of space, but essentially we are saving the same number. 41 in hex is equal to 65 in decimal. And if you are following along using a notebook, you may want to expand this whole thing in binary as follows. So the box with a blue background represents a bit, while the box without the background color will represent 8 bits or a byte for this tutorial, okay? We mostly use hex numbers in the world of computers as a short form of binary because that saves us some writing by 4 times. If you don't quite understand hexadecimal number system, you may want to check the video on binary numbers, which explains the basic idea of a positional number system. And I think if you understand the basic idea of using symbols or digits at different positions to represent a number, you will have understood all kinds of positional type of number systems, binary, hex, oct being a few of them. Anyways, so we can represent the code point 65 in 16 bits as this. But is this the only way? I mean, can we not represent it like this? That is, we start storing from the most significant byte first. And it does kind of looks counterintuitive, that is, why would anyone want to do that? But as soon as Unicode said that, we'll use 16 bits or 32 bits for UTF-16, companies in their eagerness to say that their hardware or software supports the latest UTF-16 started using both ways of encoding. That is, some companies use the first format while the others use the second way. And of course, to us, it may not make sense, why the second option is reasonable. So to put things in perspective, consider this. And remember that we were still in the C programming days when all these things were going on. If you are familiar with C programming, you would know that one would write this kind of a code to get an array of integers of size 6. And the address that the operating system returns would be that of the first byte. So the variable ptr_1 points to the first byte in the whole sequence, and the way memory is laid out, all the subsequent integers can be accessed by just incrementing the previous memory address. So if data is stored in 2 bytes, we will need to store it as an array of 2 bytes, isn't it? Because during the C days, we either had a char data type, which was like a byte or 8 bits, or we had an int data type, which was, well, usually 32 bits. So the pointer would point to the first byte, and if we know that it only contained ASCII text, which was quite a common case in those days, to be able to read the data, the pointer must move to the second position in the first case, while it could be read immediately in the second case, and then one could go to the next character. So the second format seemed to be more efficient for certain kinds of operation, both at the hardware and the software level. The first form came to be known as the little endian because the data is stored in the least significant byte first, while the second form is called the big endian form of UTF-16 encoding because the data is stored in the most significant byte or the higher order byte first. Alright? If you didn't understand the memory and pointer stuff, it's alright. You just need to understand that there are 2 forms in UTF-16, the big endian and the little endian, which is yet another problem and causes a great deal of confusion. Also, for people using ASCII, if they adopt UTF-16, their data size would still be double. Now, what is the problem of having 2 different types of encodings for UTF-16? If you had to read a sequence of characters in a file and, we are told that the encoding is UTF-16, will we be able to read the file? Well, not quite, One has to know whether it is in the big endian or the little endian form. So to hint at which type of encoding it is, an additional non-character data was added at the beginning of the file, which could be 255 followed by 254. And this is called the byte order mark, telling how the bytes are ordered in the file. So for little endian form, the 254 data is saved in the least significant byte, and in hex, it can be written as FFFE. Because in hex, FF is 255 and FE is 254. Whenever we write a number starting with 0x, it means the number is in hexadecimal form, okay? Byte order mark is not
these videos. This might be interesting to show, watch. This too.
Now we know that we can
I'm going to be teaching you basically how computers
Today,
work, more or less. How computers...
Okay, I think I'm gonna watch all these videos, but I'm gonna do it on my own time. And I'm also gonna change the thing that's wrong with the banner. And, yeah, let's see how many hours I spent here. Okay, not that much, but it's fine. So back another time. See you.